All right, we're going to do the odd factorial using a recursive function. So first we'll remove this because that was just there so the code would compile. Now, first of all, you notice the user can send over an even number. So I'm just going to put a test in here that says if n is even and n modulo 2 equals 0, then I'm going to subtract 1 from n because we just throw away the top number if it's even, as shown by the 6 example. Odd factorial of 6 is 5 times 3 times 1. So anyway, this will just happen once, but that makes sure that we're only dealing with the odd numbers. And now we can check for the base case if, I don't know if I can just check for 1, so I'm going to check for less than or equal to 1. So if n less than or equal to 1, then we're going to return 1. That's because factorial of 0 is 0. And factorial of 0 is 1, and factorial of 1 is 1. That's just going to cover our n cases. And then otherwise, we're going to return n times odd factorial n minus 2. So we're going to go down by 2 each time. Top line, make sure we're dealing with an odd number. Then this one is the base case where we bail instead of calling itself recursively if we're all the way down to the bottom, the 1. And I bet it's just equal 1. We'll check it in a sec. Because if we're starting at an odd number, then it's definitely... No, what if it started with 1? No, yeah, I bet this will work fine. By the way, these are the right numbers, obviously. But I think if we just check for 1, we'll be fine. We didn't have to do less than or equal to. Yeah. All right, there you go. These are easier than they seem, huh? You know, if you couldn't do it, had no idea how to start, and you watched my video, awesome. Glad you're watching my video. Like and subscribe. Just kidding. You don't have to do that. It doesn't make any difference. Anyway, if you had to watch my video to figure this out, then you should do it again later. Just try again tomorrow without watching the video, without looking at your solution. That's my advice.